Hello everyone, my name is Gopi Krishna and I am a data science and business analytics intern at the Sparks Foundation. As part of my curriculum, I am doing task 6, which is prediction using decision tree algorithm. I am implementing decision tree for iris dataset. Let's look at what is decision tree. Basically, decision tree is like a branch at every point of time where it decides which class the particular example belongs to. Now, if you see the classification tree here, it has a sequence of if-else statements and it has objective of inferring which class that particular label belongs to, and it will define a region where it will decide on which class the particular example belongs to. So any ML model has similar sort of steps. Now first of all, import all the required libraries. Second, collect the data and perform the EDA to know more about the dataset. Do the feature engineering process to know more about the data. Create a model and pass the data. Evaluate the model predictions using suitable metrics. Now for the step 1, I have imported all the required libraries. Second, I have imported the data. Then I am getting few information regarding it, like the data type of each column and how many entries are there, whether there are any null entries or not, etc. Next is data.describe, which will say which will give few statistical measures or values like mean, standard deviation, minimum value, maximum value, and some quartile ranges as well. Now let's visualize the data with various plots. Basically, I am using only two plots here, that is pair plot and violin plot. Now I have used pair plot to represent the graph between the features and every other feature. Now as you can see, iris setosa, which is in blue color, is kind of different from other two features, that is iris versicolor and iris virginica, and there is some sort of overlapping between the other two. Next, I have used violin plot, which tells us the quartile range, which tells us the quartile range of each attribute or each feature. As you can see, for iris setosa, this is the 25% quartile. This is the 25% quartile range. This is the 50%, and then 75%. The same applies to other two as well. I have done for the 4 different features. Now we have learned how the data is, and we have got a few insights regarding the data. Now the decision tree should be able to find the boundaries such that it should classify each particular example to its own class. Now we are expecting the decision tree to find the boundaries such that it will classify each example to its correct class. Now let us see how this can be done. First of all, I don't need ID and species, so I will remove it off, and I will create input separate inputs and labels. And there is no much EDA process required here because the data set is simple. If the data set is too large, then there will be a lot of EDA process which requires to be done because to bring the data into clean shape and structure. I have imported the decision tree classifier. Then I have used the train test split to split the data into two parts. I have imported few libraries to visualize the decision tree, like how exactly it classifies at each step. I have used the criterion as entropy. It gave me the better accuracy for this particular data set. As you can see, at every point of time it says which feature has which quantity or which value so that it can go to one particular class. As you can see, at every point of time it will specify which particular example should go away based on the decision making. Now to evaluate the model, I am using different metrics, but commonly known metrics are accuracy, precision and recall. There are many more. But for this task, I am using accuracy as a metric. Now I am importing it from sklearn, and I have got an accuracy of 98% for the training data and 97% for the test data. Now I have used the confusion matrix to plot the predictions of the model and to see how well it has performed. As you can see, there is only one example which has been misclassified by the model, and I think the decision tree was able to successfully classify each and every example. And with this, the task is completed. Yeah, that's it. Thank you.